Hello everyone, welcome to Source's classes. This is Tushar Shaw, and in this video we will be continuing to solve the GATE 29 sorry GATE 2021 questions CY that we were solving since the last I guess 9 videos, some videos I guess, we don't know. So I forgot the count. There are so many videos, and so such a big question paper this is. So anyways, so in the last video we did up till question number 22, which is I guess the last question for this video would be the last video for the 1 mark type questions, because after these three, that is from 23 to 25, we did question 22. So we'll be starting from question number 23 in this case. So after the question number 25, we'll be moving to the 2 mark MCQ type questions. Okay, the 1 mark that questions will be finished, and we'll be moving on to the that type of questions. Okay. So let us not waste any time and clear this up. So the question number 23 says that the compound of the number of signals of the HNMR spectrum of the following compound is. So the compound that is drawn is, so let me draw the compound. Here we have Br, here we have double bond O, this we have double bond O, and here we have double bond O. Okay, so this molecule can be divided into these, like a molecular plane, sigma plane can be passed from this part only. Okay, so if we divide this, so there are two identical chemical environments, so any one of them shall be considered, and we'll be getting the product accordingly. Okay, so here would be one type of hydrogen, here would be one type of hydrogen, and here would be one type of hydrogen, and therefore the total number of hydrogens that exist in this compound in CdCl3 at 25 degrees Celsius is equal to 3. Okay, so 3 here would be the correct option. Okay, so this is basically a very easy question. Moving on to question number 24. So a 5-watt battery delivers a steady current of 1.5 ampere for 2 hours. Okay, so the voltage given for the battery is, voltage is equal to 5 volts. The current is 1.5 ampere. Okay, the time given is 2 hours, or we'll be converting it as voltage and ampere ball. All of them are in the SI units. We'll be continuing the converting this in also into SI units. That is 2 into 3600 seconds, which is equal to 7200 seconds. Okay. So the total charge that has passed through the circuit is dash coulombs. Okay. So we know that charge is equal to Q is equal to I into T. Okay, where I is the current and T is the time. Okay, so here the value of voltage is not required. There it is just there to just confuse you and nothing else. Okay, so the value of I is 1.5 ampere into 7200 second, which gives 10800 coulombs. Okay, so obviously the answer required is in coulombs. So in the chat box you will be writing exactly 10800. So this is the exact answer. Okay, so 10800 being the correct answer. Moving on to the last question of this part. Okay, so this question says that we have to calculate the spin only magnetic moment of CO H2O whole 6 2 plus, and this should be rounded off to 1 decimal place in Bohr magneton. Okay, so so in this case, firstly we have to calculate the number of unpaired electrons in the system, and then we can put the value, and the obviously we have to calculate the spin only. So just the number of unpaired electrons would do the job. Okay. So so CO2 plus. So we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, which is 4s2. So cobalt the system is 4s2 3d7. Okay. So here we have CO2 plus, as H2O is neutral. We have CO2 plus to be 3d7 system. Okay, so let us draw the CFT diagram. Energy we have for an octahedral system, obviously the coordination number is 6 here, so it is an octahedral system. So 3d7, it has firstly pairing up would be taking place. Firstly, the as H2O is a weak field ligand, so firstly the electrons will be occupied in the orbitals, and then pairing up would be taking place. Okay. So first electron, second electron, third electron, fourth electron, fifth electron. 5 electrons are there occupied. Then sixth electron, then seventh electron. So the two sets of electrons are paired, and three of them. So three unpaired electrons are obtained. Okay, unpaired electrons are obtained. Now what would happen is you have to put the value in the formula for the spin only magnetic moment, that is mu SO is equal to root over n into n plus 2 Bohr magneton. Okay, Bohr magneton. So we put the value of n equal to 3, as we have got 3 unpaired electrons. So 3 into 3 plus 2 Bohr magneton, which gives 3 root over 3 into 5 Bohr magneton, which is equal to root 15 Bohr magneton. Now let us calculate the value of root 15. Root 15, this comes to be 3.872873, you may say. Okay, Bohr magneton. Okay, so obviously this is the correct answer, but as I have told you already in the previous video, that you have to follow the question strictly, and the question says that to round off to one decimal place, so this will be rounded off to 3.9 Bohr magneton, and in the chat box you will be writing 3.9 as your like unit also not required, so 3.9 would being the correct option. Okay, so this is how you will be writing. Now obviously that this section is now complete, so the 1 mark session is totally finished. We did the MCQ, MSQ and the NAT type questions. So now we are from question number 26, we will be moving on to the MCQ type questions again. Now this would be having 2 marks for the correct answer, and minus 2 by 3 will be deducted if the answer is wrong. Okay, so for this kind of questions, you will be so let us start from question number 26 in this case. So the question number 26 says that a complex is given. The complex name, the name of this complex is tetrakis 1 non bornyl cobalt. Okay, so the structure that is given here is let me draw the structure. CO. Okay, so this is the structure that is given. Obviously made a mistake here for CO. Okay, so the question is that we need to find out the geometry and the number of unpaired electrons in this structure. Okay, so firstly you have to note down that this complex has CO 4 plus. Okay, this is one of the very extremely few and extremely rare compounds that has a stable oxidation state 4 for the cobalt metal ion. Okay, so this is extremely stable and very rare. Okay, yeah, so this is the case. Now what would happen is, if you in the options you can see that either from not the options, you know that this has a coordination number equal to 4, so either it will be a square planar complex or it will be a tetrahedral complex. But in this case you can see the if the complex is a square planar, okay, the angles between each of the ligands would be 90 degree, and if it is tetrahedral, the angles between each of the ligands would be 109.5 degree. Okay, so obviously as these ligands are extremely huge, so they would prefer to stay in the 109.5 degree space than in 90 degree space. Okay, so obviously then by this we conclude that the structure would be having a tetrahedral geometry. Okay, so this is the one thing. So option A and B have one tetrahedral, and option C and D have square planar. So we'll be cutting out option C and D. Those won't be the correct answer. Okay. Now for a tetrahedral geometry, let us draw the CFT diagram. Okay. E. This is T2. I'm sorry. This is E and this is T2. Okay. So there are cobalt 4 plus system is taken. Okay, cobalt 4 plus. So obviously we know that cobalt is a 4s2 3d7 system normally. Okay, 3d7, yeah, 3d7 system, but in this case we will be having 4 plus, so cobalt 3d5 would be present. Okay, so two electrons firstly will be moving here, then obviously this ligand is a strong is a weak field ligand, so therefore uh, firstly this would be happening, and then one electron would be in the present in the unpaired form. Okay, so this is obviously yeah, so this is the exact case that would be happening. One electron would be there as a remaining unpaired, so the number of unpaired electrons would be equal to 1. And you must note that this the ligand that is given, it will be used like you can use this for further purposes. This ligand obviously is a strong field ligand. Okay, we do not study about these such huge ligands in coordination chemistry, but this is for just an informative type question that as the ligand is very bulky and it supports the higher oxidation state of CO of cobalt, and therefore this is a strong field ligand. Okay, so tetrahedral, and the geometry is tetrahedral, and the number of unpaired electrons is 1. So in the options you can see that A option A has this option, so option A will be the correct one. Okay, so let us end this video here. We did 4 questions in this video, and obviously like after 7 to 8 videos, we will be completing this set of questions, and then we will be moving on to the BHU set of question paper. Okay. Obviously, that is a like for the that part is a bit later. So let us firstly concentrate on solving this for these types of questions only. Okay. So from this video onwards, we have after the next video onwards, obviously we will be solving just the 2 marks question of MCQ, MSQ, and NAT, and then we'll be completing the set. Okay. So thank you guys for this video. I'll see you guys in the next one.